Some shapes roll in a straight line. Some roll in a curve. And some shapes roll in peculiar and seemingly surprising ways. But what if I told you that the strange swaying of this particular shape is not as unpredictable as it seems? In fact, this shape has been designed to follow a very specific path. And according to new research, for almost any path that you care to draw, a shape theoretically exists that can follow it. Oh, and this mathematical puzzle could help give physicists a new way to think about the quantum realm. Not just a wobbly shape then. It started off as a curious mathematical challenge for a group of researchers. Could they design a shape to roll along any given path? The approach they came up with was quite simple. Take a sphere of clay, roll it along your chosen path and push down while rolling it. Hey presto, the indentations formed will lead it to follow that particular path. Based on this principle, the researchers designed a computer algorithm that could determine the precise indentations needed to make any path. But an even bigger challenge was to make it keep going, tracing the same squiggly line over and over again. For this to work, the rolling shape has to finish the path in the exact same position that it started. The researchers modelled this by drawing the squiggle over the surface of a sphere. If they could make the starting point the same as the end point, then the pattern could repeat. And using this method, they were able to come up with loads of interesting rolling shapes, far more variations than had ever been invented before. But it didn't always work. Some patterns just couldn't meet at the end. So they developed a workaround. If they could trace each squiggly path twice on the surface of the sphere, a solution was much easier to find. This means that the rolling shape comes back to its original position after tracing the path twice. For this condition, the algorithm could design a shape for almost any path you can think of. So many, in fact, that it's almost impossible to find an example it doesn't work for. That's in theory, anyway, and with the algorithm's ideal conditions. But the team wanted to be able to make real physical objects that actually worked. With 3D printing, it was simple enough to create the precise shapes, and inserting a steel ball bearing in the centre made them heavy enough to roll properly. After that, their problems weren't so much mathematical as practical. In the real world, sharp corners proved difficult, though not impossible to achieve. Similarly, paths that go uphill or cross over themselves were a bigger challenge. And they found that you have to have just the right materials, the right friction between the surfaces, and a certain slope angle to make these funky shapes roll their best. Still, by the end, they'd come up with an enormous number of new possible strangely rolling shapes. But why? Well, what started as just a fun challenge could actually have some potential relevance to other areas of science. Quantum states are often represented as points on the surface of a sphere, with a change of state being equivalent to a path across that surface. It's possible that this quirky mathematical discovery could be applied to quantum computing or quantum optics. But regardless of that, right now these researchers are happy to have shown something no one else has before, a mathematical principle demonstrated in the real world with a whole host of surprising rolling shapes.